In bell work, we're trying to figure out a particle moving by that position equation. When is the particle speeding up or slowing down? Okay. If we had our calculator, that'd be great. This is not a calculator question here. Okay, so we could look at a graph of velocity. You'd be very comfortable with that. Okay, but we're doing it slightly different. Particles speeding up or slowing down. We need to look at velocity versus acceleration. Okay, what do I need to do here to find velocity? Take the derivative. What is my derivative going to look like here, Max? 6t squared minus 18t. So we took the derivative. Now he wants to know when that's 0 or undefined. It's not going to be undefined, so it's just 0. What did you factor out here? 6t. He's left with t minus 3. We take each thing and set it equal to 0. T is 0 and 3. Get on the first part. We throw it on a sign chart. That's velocity. So 0, 3. If I plug in 1, it would be negative. Positive, positive. If you don't believe me, just plug in some numbers. We're plugging them back into the derivative. If you plug in any number bigger than 3, like 4, it's positive. You plug in 1, you get a negative number. You plug in negative, you get a positive number. Good? Once I find velocity, if I want to talk about speeding up or slowing down, I have to do both velocity and acceleration. Okay, that's all we talked about yesterday. Okay, so the next thing I got to do is find acceleration. So Jalen, what's my acceleration going to be? Good. 12t minus 18. We take that thing, set it equal to 0. So 12t equals a positive 18. Divided by 12. T is 3 halves. I'm going to put that on a sign chart. But specifically because I'm comparing velocity and acceleration, I'm going to put it right here and throw 3 halves where it would fall in relationship to the other one, because I think it'll better help us understand what's going on. All right, so I'm picking a number bigger than 3 halves, like a billion. If I plugged a billion in right there, it would be positive. If I plugged in a number less than 3 halves, like 0, I would get a negative. Everybody good to that point? The last thing I'm trying to do is talk about speeding up or slowing down. What is going to be happening with velocity and acceleration if I'm speeding up? Same sign. So I'm looking for same sign. So Jonah, when is some time that I have the same sign? Greater than 3. Because 3, velocity is positive and acceleration is positive. Okay, so from 3 to infinity, they're both speeding up because they both have the same sign. Max McCain, when else am I speeding up? 0, because from in between 0 and 3, I'm negative, and less than 3 halves, I'm negative. So between 0 and 3 halves, I am both negative. And if I'm both negative, that means I'm also speeding up. It would all be parentheses because we're talking about the second derivative, because we're talking about velocity and acceleration. That's speeding up. Then we're going to talk about slowing down. So obviously slowing down is going to be the other intervals, like between 3 halves and 3, because this one up here is negative and this one down here is positive. When you have different signs, then you're slowing down. Okay, it might have been better maybe for me to put a whole bunch of plus signs there and a whole bunch of minus signs here and a whole bunch of plus signs here so you can kind of see that change. So right there, they're both different signs. So we're slowing down between 3 halves and 3, and I'm also slowing down when I'm less than 0 because the signs are different. So from negative infinity to 0. Questions on speeding up versus slowing down? We can do that with a graph. On a graph, we're good with that, but you don't need a graph either. It's just understanding what am I comparing, speeding up and slowing down, velocity and acceleration. Questions there? Let's do bell work part 2. So just keep it on your bell work. Look at this problem. First period, I had 0 students get it correct. Okay. This would be a multiple choice question. This would probably fall in the calculator portion, but you would absolutely not need a calculator here. They just always throw problems that you need a calculator or you don't need one on there. Read through it. Think about it. If they gave you the information, you're going to need it most of the time. Okay, make sure you're utilizing stuff. Talk with your neighbor. Figure out at what x value does g of x have a relative maximum. You're trying to figure out when does g of x have a relative maximum. Talk with your neighbor. Figure it out. Go. Let's look. Okay, you've got some random dots here. We did g of x. Okay, cool. I graphed it out. G prime. What is g prime going to tell me? Slope. So g prime at this thing is negative slope. Here it's 0. Here it's positive 3. Here it's 0. Here it's negative 1. Anybody pick a maximum at 6? That is not correct. Okay? Max, why did you pick there to be a maximum at 6? If you look at the first derivative at 6, what happened that made you figure out that it was a maximum? It changes from positive to negative. And so if we just use that concept, you're not wrong, but that's kind of the trick here. They're making you think that that is true, and that is not what we're doing. Because, yeah, the slopes there and there are going on, but look at the graph. Like, it doesn't really match up anyways. And they might even make, the one I stole this from was harder than this because it looked like a maximum. Okay? But by giving us just values, it doesn't tell us anything that's happening in between. Maybe my graph did this. Whee! I don't know. Like, it doesn't tell me anything but points. And just points being spread out didn't tell me enough. So it's not 6. 6 is actually going to be a minimum. And the way I can tell that is this guy right here. This is G double prime. What is G double prime going to tell me? Concave up, concave down. So Max, you want to go from there? Four is concave up. Okay. It's not 5. But what about 2? At 2, G double prime is negative 1. What's that going to tell you? It's concave down. What else do I know is happening at 2? The slope is 0 and I'm concave down. Think about a graph. If you are concave down and your slope is 0, what does that tell you about that point? It's a max. The only other one I know for sure is 6. Okay? The slope is 0 and I'm concave up. Well, concave up with a slope of 0, that makes 6 a minimum. The rest of them are just random points. Okay? But there's a maximum here at 2. Remember, we taught this one day. It's been a few weeks, maybe since we've done it. But we did this when we talked about the second derivative test. Okay? That's the second derivative test. That if we know the slope is 0 and the concavity, that can tell me whether something's a max or a min. Kind of makes sense what we're doing there? That one's a tricky one.